In this lesson, we'll cover systems of nonlinear equations. And what that means is when you have more than one equation, at least one of them is nonlinear, like this one here is a quadratic. We're going to solve this by using the substitution method. The way this will work is we look at one equation and solve for x or y, and then plug that into the second equation. So when I look at these two, I think the simplest thing to do is take this for y, this x squared minus 4, and plug it in right here. So that is, I'm taking this y, and I'm plugging it in right there. So this will take two equations and reduce them down to one, and that one equation is x plus, instead of y, I'll put x squared minus 4, and that's equal to 2. So I now want to solve this equation. I think I'll do that by subtracting 2 from both sides of the equation, making this side 0. When I do that, let's see, I'm going to reorder things too. On the left, I'm going to put the x squared first, then the x second, and if I subtract 2 from both sides, I get minus 6. Written this way, I think we can factor this quadratic to find the solutions. I need an x and an x. I need a positive and a negative because of the negative 6. And I think the numbers are going to be 3 and 2. The product is negative 6, and they sum to a positive 1. This means there are two solutions for x because we have two equations, x plus 3 and x minus 2. The first one, I get that x is equal to negative 3, and then the second one, I get that x is equal to positive 2. Now, the solutions have more than just x's. It should be an x and a y, so we need to find the corresponding y values. So when x is equal to negative 3, what is y equal to? Well, we can use either equation we want to solve for y. I think I'll use the second one. Y is going to be equal to negative 3 squared minus 4, which is 9 minus 4, which is 5. This means one of our solutions is negative 3 comma 5. Now there should be another one. So when x is equal to 2, what is y equal to? That is, y is equal to 2 squared minus 4. Well, that's 4 minus 4, which is 0. So the other solution is 2 for x and 0 for y. So it turns out for this system, there are exactly two solutions. With a linear system, there's either one, none, or infinitely many. But here, with nonlinear, you could potentially have 2, 3, 4, 5, and so on. Just to take a second look at that first example that we just completed, here I graphed both of these equations. The one in red is x plus y is equal to 2. And the second one is our quadratic, which is y is equal to x squared minus 4. And the thing to note is these two equations intersect at two places. There's one spot here and another spot here. And what are these points? Well, this one is negative 3 comma 5, and this one over here is 2 comma 0. Those were the two solutions that we got on the previous slide. So when you're solving a system of any equations, you're trying to find where they equal each other, and it was these two spots. Okay, in example 1, I want to solve this system of nonlinear equations, again by using that substitution method. So the second one is a line. This first one is actually the equation of a circle. I think what I'll do is solve the second equation for x, because I can add y to the other side, and I'll plug that in place of this x here. So that's my strategy. This is not the only way to do it. It's just the first thing that occurred to me. So x is equal to y minus 2, because I added y to both sides. I'm now going to take this value for x and plug it in right there. Here's what we end up with. We have x, which is really y minus 2, squared, plus y squared, is equal to 34. Okay, to solve this, I think what we have to do is square out the y minus 2 and then combine some like terms. So y minus 2 squared, we gotta be careful here. It's y squared, And the negative 2 times negative 2 is a positive 4, but there's also two middle terms. You get a negative 2y and a second negative 2y because you get negative 4y. So here, I'm really foiling out the following. This is really y minus 2 times y minus 2. Okay, that being said, I'll then copy down the plus y squared, and that is still equal to 34. So I square this out by foiling. I got these three terms, and I now have this y squared here. When I combine like terms, we have 2y squared minus 4y plus 4 is equal to 34. Because I'm dealing with a quadratic, I think I'm going to make this side 0 by subtracting 34 from both sides of the equation. And when I do that, I get 2y squared minus 4y minus 30 is equal to 0. Oh, I can see that both sides are divisible by 2. That'll reduce the equation, make it a little bit easier to work with. So if I divide the left by 2, I get y squared minus 2y minus 15. And on the right, I'm left with 0. I think this factors. We have a y and a y, a positive and a negative. I think 3 and 5. So I'll do a positive 3 and a negative 5. The product is negative 15, but the sum is negative 2. This means I have two solutions. One of them is y is equal to negative 3. The reason is if you put a negative 3 here, it makes this whole factor 0. Likewise, y is equal to 5 is a solution as well. Now these are just y values. We actually need points. To solve for the corresponding x values, I'm going to use this equation here. So to start with, when y is equal to negative 3, x is equal to negative 3 minus 2, or negative 5. This means our solution is negative 5 for x and negative 3 for y. For the other y value, that was y is equal to 5. Going back to the same equation, x is equal to 5 minus 2, and that's equal to 3. So our other point is 3 for x and 5 for y. And those are the two solutions to this system. Okay, in example 2, here again we have a linear equation, but this one's not linear. Let's see, how can we solve this one? Again, by using a substitution method. I think what I'm going to do is take the first equation and solve it for y. I'm going to divide x to both sides, so that's 24 over x. I'm now going to take this value for y and plug it in right there. The equation becomes, we get 3x minus y, which is really 24 over x, and that's equal to negative 6. This thing. Okay, how can we solve this equation for x? I don't like this fraction. I want to get rid of it. And the way I'll do that is by multiplying both sides of my equation by x. The reason is that when you distribute this x to this fraction, you'll have an x in the numerator and one in the denominator, and they will cancel. So x times 3x, that gives us 3x squared, minus, well, x times 24 over x is just 24. And on the other side of my equation, I just have negative 6x. I think I'll add 6x to both sides. So I get this. And let's see. Oh, I can divide 3 to both sides of this equation. I get x squared plus 2x minus 8 is 0. I think this factors. Let's see. Have an x and an x, a positive and a negative. Okay, that's going to be a positive 4 and a negative 2. The product is negative 8 and the sum is positive 2. Therefore, x is equal to 4 and x is equal to 2. Of course, we need the corresponding y values. So let's see. When x is negative 4, y is equal to, I guess I'll use this equation here. I'll put negative 4 here, and let's see what we get. That's 24 over negative 4. That is negative 6. Therefore, negative 4, negative 6 is a solution. Looks like there's going to be one more. When x is equal to 2, y is equal to 24 over 2, which is 12. So we get 2, 12 as the other solution to this system. And in example 3, again, we have a system of nonlinear equations. In fact, neither equation is linear. I think what I'll do is solve the first one for y, and then take this y and plug it in right here. So I get x squared plus, okay, I'm putting 6 over x in place of y, and that whole thing is being squared. That's equal to 37. Okay, I think I have to square the fraction, which means I'll square the numerator and square the denominator. So that's x squared plus 36 over x squared, and that's equal to 37. Again, I see this fraction. I want to get rid of this denominator. I think the simplest way to do that would be to multiply the left by x squared, and therefore multiply the right by x squared. When this x squared gets multiplied to this fraction, it'll cancel, leaving us with 36. X squared times x squared is x to the 4th. When I multiply x squared to 36 over x squared, I'm going to get 36. And on the right, I have, well, that's just 37x squared. This isn't a quadratic equation because we have a power of 4. However, I still think we can take a factoring approach to solving this. That is, I'm going to subtract this to the left side of the equation, so this side is equal to 0. We have x to the 4th minus 37x squared plus 36 is 0. I think what we can do is still set up a couple of parentheses, and here I don't have an x squared, I have an x to the 4th. But that means here and here, I'm going to put x squared and x squared, like this, because x squared times x squared is x to the 4th. I have a negative here and a positive here, which means I have to have two negatives, because a negative times a negative is a positive, but if I add two negative values, it will stay negative. I need two numbers that multiply to a positive 36, yet add to a negative 37. I think that's going to be a -1 and a minus 36. The product is positive 36, and if I add those together, I get negative 37. This is perfect. I can now take both of these equations and set them equal to 0 and solve for x. I'm going to do that over here where there's a little more room. I want to solve x squared minus 1 is equal to 0, so this factor here. First, you would add 1 to both sides, and then you have to take the square root of both sides. But when you do this, you actually get two solutions. You don't just get positive 1, but you get negative 1 as well. Likewise, with x squared minus 36 is equal to 0, again, you would add 36 to both sides. It's supposed to be a squared. Now when you take the square root of both sides, you get that x is equal to not just 6, but negative 6. This means there are actually 4 different x values that you have to consider. So that's x is equal to negative 1, positive 1, negative 6, and positive 6. And then for each of these x values, there's going to be a corresponding y value. I'll put those down here. For negative 1, 6 divided by negative 1 is negative 6. For positive 1, 6 divided by 1 is 6. For negative 6, 6 divided by negative 6 is negative 1. And then this last one, 6 divided by 6 is positive 1. Okay, this means there are 4 solutions. I'm going to write them, running out of space, I'll put them over here. When x is negative 1, y was equal to negative 6. When x was equal to 1, y was equal to 6. When x was equal to negative 6, y was equal to negative 1. And when x was equal to 6, y was equal to 1. So there's actually 4 solutions to this equation. And that is it for example 3.